All right, guys. So, shall we start? So, could you go back to your seat? And somebody, could you check the YouTube if we are online? Can you hear us? Hello? Yeah, yeah, something like that. All right, so thanks for coming. This is a very, very special event tonight because this is the 50th Tokyo.NET Developer Meetup 5.0. Yay! We only have 10 to 12 events per year, meaning this could be our completely 5 years. And I think next year going to be our 6th years. And today we are at the Azure, what's the name here? Azure Daikaiwa base, and we have the hashtag Azure DKY, and whenever you tweet something, Azure base DKY. Alright, let me fix that. Give me some time. Azure. And there you go, Azure base DKY. So whenever you tweet, and please add in this hashtag in Twitter and Facebook. Alright, so we have two guests, and one of the, of course, the Jamie, always the speaker, and he's very special. But even though we still have the very, very special speaker tonight, coming from the where one? Seattle. Seattle here, so he's talking about the ARM template. But how many people know the ARM template? What? ARM template, ARM. And do you know what ARM stands for? No, Azure very matters. But that's the ARM template, so, so it's all yours. Wait. Is this working? Yeah, it should. And whenever you guys have a question for the online people, please come into the microphone and ask you any question. Great. And let me just switch to the HTML. There you go.
Cool. Awesome. So is this on? Can you hear me? Awesome. How about that? Is that better?
Yeah, that's on.
Awesome. So my name is Neil Peterson. I work for Microsoft from Seattle, Washington. I'm here for the Ignite tour. Honored to be here. So thanks for having me. So we asked the question, who knows what an ARM template is? And I think there was 3 hands. Is anybody working with Azure?
I do.
So it's about the same 3 hands. So I think what I'll do, so what I was going to do is kind of what's new with ARM templates. But I think what I'll do is also just introduce ARM templates and kind of talk through what they are end to end. And then I'll filter in kind of some of the what's new stuff. So let's get started.
Right, and we are seeing here. So maybe you want to reshare your screen, please. Thought we should be able to see that.
I'm not sure what I need to do.
No, it's a straight thing.
So the thing is I've got a remote desktop.
Yeah, we see your remote desktop. So if you...
Maybe if I close that.
Yeah. Sorry about that.
No worries.
And if you... So this is currently shared. And if you just try to share... Yeah, stop sharing. Let's share it again, please. We still see your remote desktop.
No worries.
Why is that?
Hopefully it works out.
We have no idea.
Remind me why you picked this tool.
Nah, it's kind of working. But this is showing his second display.
Well, I only have one display here. And to me it looks like it's frozen or something.
Yeah, let me just switch back to my screen and make sure we're on the same page. All right, could you share your screen again? So this is what I'm seeing right now. So this is the screen you are sharing in the application.
I don't know how to change that. I mean,
What is the screen, by the way? No.
yeah, I mean, I don't have.
That's weird. Could you just try to just leave and rejoin to the meeting?
All right.
Thank you.
Is that your screen or his?
This is my screen.
Why don't you just maximize that one?
I do, but he tried to sharing the different screen.
Oh.
Yeah. He tried to sharing the slide, not the code. Alright, so I see you join. There.
All right, does that work? Okay. Now I'm going to flip around to a couple different things, so I guess just keep our eyes on it and make sure that.
Right, and I put back to your screen. Yes, we go.
All right, cool.
Yep,
All right.
this is for you.
Okay, cool.
Yeah.
All right, so again, I'll introduce our templates, go through it, and we'll look at some of the new features as we go. So, basically with any cloud provider, obviously we've got things that we deploy into that provider resources. So things like virtual machines, virtual networks, storage accounts, databases, containers, whatever they might be. And we've got a bunch of different ways we can deploy these. Kind of speaking generally about cloud providers, whether it's Azure or AWS or Google. For instance, in Azure, we've got a portal, which is a tool that you can use inside the browser, and you can click New Virtual Machine and configure that virtual machine straight from the portal. But obviously, that doesn't work in kind of an automated or scalable way. We also have command line tools. For Azure, we've got something called the Azure CLI. We've also got a PowerShell module for Azure. And these are tools that you can use to script and from a command line do the same things that you can do in the portal. Deploy your resources and configure your resources, delete resources. But then command line tools are great, but we've also got this other thing called ARM templates, which is instead of like a command line tool or a scripting tool like a PowerShell module where you create the resource and you configure it in kind of a scripted way, with an ARM template, we're basically building essentially what's a JSON file, and we're declaring the configuration. So instead of doing something like new virtual machine with the parameters necessary for configuring that virtual machine, we can use this declarative document that can then be deployed to Azure, which will deploy whatever resources that you configure. So the question might be like, well, we've got, obviously, the portal is a very manual task, but at cloud scale or at production scale, we want automated tasks. So why would I use, if I've got command line tools and PowerShell modules, why do I need an ARM template? And the big difference, in my opinion, is this concept of idempotency. Is anybody familiar with the term idempotency? I struggle to define the word idempotency, but it means that in the context of an ARM template, it means I can take this template and deploy it to Azure. and it will create my resources. I can then take the same template and deploy it again, and I'll get the same results. So if I don't modify that template, when I deploy it, it will, basically the engine will say, oh, hey, well, this virtual machine's already there, and it's already configured, so there's nothing for me to do here. And then if I change something, like maybe I add a tag, or I change the disk size, and I redeploy it, the template will recognize, oh, okay, we've made an update here. Let me go ahead and reconfigure this resource to match that update. And that's really important because if you try to do that with a script or the command line tools, it's a lot of work. You're going to have to write loops and checks, and you're going to have to write all that logic yourself. And then there's a bunch of other little reasons why you might want to use an ARM template, but I think idempotency is kind of the big one. So if I've got systems, maybe I've got a e-commerce system, and every time somebody logs into that system, I create a resource in Azure. I'm going to want something that will kind of idempotently create that resource and manage that resource for me. So there's some other things in there, but I really think idempotency is the big one. So I kind of think of it as kind of the most mature way to build systems that automate deployments to Azure. If you're familiar with AWS, they have an almost identical solution called CloudFormation, which is, again, JSON-like files that do something similar. I'm not familiar with the other cloud providers and what they have. Some features of ARM templates, they can be parameterized. So I can create an ARM template that deploys a large solution, not just one resource at a time. Maybe I have an ARM template that has 6 virtual machines, a bunch of networking stuff, a SQL server, some containers, and then configures them all to work together. And then maybe I need to deploy that for all of my customers. So I can parameterize it so that I can input different data so that I get different results, like different individual deployments. We can write modular templates. In fact, we were just talking about this. I'll show an example of a very simple template and then kind of a more complex one. But just kind of like with a lot of modern programming languages, we can break them down into individual files. So in that example where I've got a bunch of virtual machines and a bunch of networking and data stuff, maybe I want my virtual machine in one file, my data stuff in another file, my networking stuff in another file. We can do that and link them together or nest them together. We can test them. And then the other cool thing is, we're writing this stuff in a JSON-like language, and I'll kind of touch on the language and why I'm saying JSON-like. So we can do things like put them in source control and run them through CI/CD solution or systems. So that's essentially it. I think what I'm going to do is, instead of going just into the what's new stuff, let's just take a look at an ARM template and kind of play around with them and just see what they do. And this isn't planned, so we'll just have a fun time playing around with it, and I'll just kind of do whatever makes sense. And if you've got questions or if you want to go a different direction, just let me know. And then we'll get into some of this stuff, and some of this stuff we'll actually cover as we're playing around. So I think, let me just make sure that this thing refreshes.
Yeah. Kind of stops forever by some reason.
Is it just latent, it's just taking its time refreshing, or?
Nah, I don't think so, because this guy usually working quite fast.
Oh, the other thing is it never went to my name. It's still on the very first slide.
Yeah, so it's never coming back to it. So this is what people are seeing right now.
So I'll let you tell me what you want me to do. I can.
You know what? We are seeing that now. Cool. By some reason. Anyways, no worries. Yeah.
Okay.
This is what we see.
Okay.
Yeah.
Do you want me to jump out and jump back in? Or?
No, that's okay. No worries. Yeah.
Okay. All right. Cool. So as I was talking about, Oh, it's actually updating now.
Yeah.
Looks good. So this is the Azure portal if you've never seen it. So I can come in here and click create a resource, and maybe I want an Ubuntu server. And I can fill out this form, hit submit, and I'll get an Ubuntu server, but obviously, that works great for one-off stuff, but not super duper scalable, or wouldn't work in any kind of automated solution. And then speaking of command line tools, so we've got something called the Azure CLI, and I'm just kind of showing off some of the tools to compare and contrast before we jump into ARM templates. So we've got this tool called the Azure CLI, which is just a common CLI tool. Can do quite a bit of stuff. I just typed in AZ, and it shows me all the commands that I can run. So whereas I went into the portal and showed how we can create a VM, I could do something like AZ VM create, and then fill this out, and I won't go through it, but I can run a single command to create a VM. But again, if I wanted to do things like check and make sure the VM, is the VM already there, I would have to write that. So I would have to write a bash script to do all that for me, whereas using a template, I don't have to do that checking, it's just built into the solution. So let's take a look at a template, and we'll deploy one, and then kind of get into some of the features. So it is a JSON file. We are we'll talk about this new thing we've got called this language service, which introduces some capabilities around commenting, adding comments to an ARM template, which JSON natively doesn't support commenting. So that's why I said JSON-like. If you do use some of our basically this team has taken JSON and really kind of building their own processing engine and are somewhat extending the capabilities. So if you do things like add comments and then run into a JSON linter, it'll come back as not valid because JSON linter doesn't understand the comments themselves. So there's a couple different sections to an ARM template. The first one is parameters. And this is I want to bring data in. Maybe I want to ask a user, or maybe it's coming from an automated solution. And we'll see some of those. We then have variables, which are used very much like parameters. It's just a piece of data that we're going to use somewhere inside of the ARM template. But I can't specify the value of a variable when I run the template, basically. We then have this section called resources. And this is where we start defining our resources. So I have a resource here called, the type is Microsoft.container instance and container group. Is anybody familiar with Azure container instances? Anybody use Docker containers at all?
Yeah.
Couple little hands. So all in Azure, and this isn't really relevant, but since we're looking at it, I'll explain what the resource is, and we're just going to deploy it and see it. All this is just a running instance of a container in Azure. There's no Kubernetes cluster or even Docker host behind it. You just run a container in Azure. It gets a public IP address if you want it to, and you can access the container. So I've given this resource a name, container group 1. I've given it the type, or I've specified the type, and this is the resource type. And there's just a bunch of different types, VMs, networking, whatever it might be. The API version, so these resources get versioned as new features are added or properties are added to the resources. We version those resources, and there may be some instances where hey, we've got this big, huge deployment on these stable versions. We know you've versioned the resource, but we want to stay 7 versions behind because that's kind of the environment that we're in right now. A location is just the location in which we want to deploy the resource. So this is the physical data centers, Azure data centers. And then we get into the properties, which are just the specific configurations of that resource. In this case, things like what port do I want to expose, how much CPU do I want to give it, how much memory, what is the OS type, do I want the IP address to be public or private, and some other things. So just in general, I'll talk about the authoring experience a little bit, very candidly. You know, looking at that, that's not pretty. It's not easy to write. It's not easy to kind of parse with your eyes, like, hey, that's like a lot of stuff there. And this is something that, you know, we at Microsoft have heard loud and clear, like these things are just painful. And this is a very simple one to contrast. You know, I've got kind of a larger one. It's not huge, but you know, there's probably 5 or 6 resources in here, and they just get very difficult to work with. I know you've worked with Terraform, but has anybody else worked with Terraform? So Terraform is an infrastructure as code solution built by a company called HashiCorp, and it's an open source infrastructure as code solution. It does a very similar thing as ARM templates. Things like the idempotent nature is again, Terraform does a very good job at that. Kind of comparing and contrasting the two, Terraform, on the other hand, is much easier to write. It gets simpler. Like, it's not JSON. They built their own like language service on top of JSON called HashiCorp Configuration Language, HCL, which is it's the same type of configuration file, but they intentionally built it so that it's easy to read, easy to write. You can kind of look at it and make sense of it much more easier than this. So actually, some of the stuff that I'm going to show is some of the improvements that we're making to try to improve the Azure Resource Manager authoring experience. They're very early, like kind of even a little more details, kind of like about the company. You know, kind of recently, several people in like leadership positions at Microsoft have realized, like, okay, it's time to get serious about this and really start putting some effort into making this easier because there are some issues with Terraform. So Terraform's taking off. Like, people are using it like left and right. The problem that I find with Terraform is that the provider, which is the piece that gives you all the capabilities to deploy stuff in Azure, excuse me, it's hand authored. That means that, like, let's take a virtual machine resource. If we add a new property to virtual machines in Azure, somebody needs to go update the Terraform provider by hand. It's written in Golang. It's bitten me in the past. I was working on a project where I needed to deploy cognitive services, and the Terraform provider didn't support cognitive services, so we had to go write it ourselves. Golang is kind of a newer language. You know, it's like, all right, who knows Go? And like nobody did. So, you know, it was this big effort to get cognitive services into Terraform, whereas ARM templates, like as soon as we version the resource, this stuff gets built automatically. So that's the benefit there. So, you know, long story short, there's a lot of effort being put into making this easier, and I'll show off some of that here. So let's just take a look at, like, okay, so I've got an ARM template. It's going to deploy a single resource, a container instance, and I'm going to deploy this. We'll see it deploy, and then we'll create a brand new file, and then create the exact same ARM template from scratch, just to kind of see what the authoring process is like. So the first thing I need before I can deploy a resource manager template, before I can deploy this one, is a resource group. What a resource group is in Azure is just kind of like a logical container, not like a Docker container, but just a container where I can drop a bunch of resources in it. Kind of what's unique about the resource group is when you create the resource group, you tell Azure what region, so what data center you want that resource group to go into. Now, we can also deploy resource groups from an ARM template, but I haven't done that here. So I'm actually going to use the Azure CLI to create a resource group. So I'll just do AZ group. I know that's kind of small. I'll just read it out as I go. AZ group create. I'll give it a name. I'll just do demo-001 and then location. And this is, again, selecting the region that I want to deploy it to. I'm going to do East US because I have kind of my Azure subscription is limited in where I can deploy stuff because I don't pay for it. So I know that I can put stuff there. And so all I'm doing now is just creating this container into which I can deploy the ARM template. So we can see it succeeded. If we just want to see that in real time, I'll just go over here to resource groups, refresh this, and what did I call it? Demo. Oh, interesting. Make sure I'm on my right account. Okay, there's, so my resource group was created. And so let's go ahead and deploy this ARM template. And I'll show a couple different ways we can deploy it, kind of some fun stuff as well. So I've got this, this file, Azure deploy.json. So now I'll use the Azure CLI to deploy it. We can use PowerShell to deploy it. We can use the Azure portal itself, and then I'll show you this cool little trick that we can do. AZ group deployment. Create. Give it a name. What did I name that resource group? Demo 01. And then I select the resource group that I want to deploy it into. And then I need to give it the location of the ARM template file. Template file. And then it's named Azure deploy.json. And I'll hit go. Oh. Yep, I just forgot a dash right here. So it's saying it couldn't find the resource group. So now it's taking this template, deploying the resource as it's configured in Azure. And then again, once I'm done, I can deploy the template again and it'll do nothing. But maybe I come in and I change like the CPU from 1 to 2. And then deploy it again, and it would, in some cases, like tear down the resource and redeploy it, depending on the property that you're changing. But some properties, like if it's just a tag, which is just like, and this is just one instance, a tag is just like a label that I put on my resource. It's not going to tear it down, it's just going to like update the tag or add the tag. So that's kind of that idempotent nature. If I go over here into my resource group, I can kind of see what's going on this end. We can see that I've got something deploying. Boom. And I'll let that deploy. And while it deploys, let's take a look at another way that we can deploy these. So I've got an ARM template. I can click on Create Resource. And I'm doing this for a reason. You know, you might ask yourself, like, why would I write an ARM template and then copy it into the portal? But you can do it. So I just hit Create Resource and then ARM template. Build your own template in the editor. And I can paste my template in here. Click Save and then deploy it. So I'll do this sometimes, like I'm just like lazy. Like maybe I've got a template that has a lot of parameters and I don't want to like tag all those parameters on the command line. I don't have any parameters in here, but if I did, when I click Save, it would actually give me a form that would allow me to fill out all those parameters. But even cooler, let me show you this little trick here. So I'm going to go over to GitHub. Is anybody going to the Ignite Tour this week? I know you are. The Ignite Tour, the Ignite event here this week? No? Okay. Well, we've got a demo environment that we use through a lot of the talks in the Ignite Tour, and we deploy that environment through an ARM template. And we've got everything stored in GitHub. So we have this ability to like create buttons or kind of like ways to share this out. And all this button does is just like a little HTML thing that takes the template that you've defined inside the button and does that same little portal trick that we just did. So if I click Deploy to Azure, it's going to open up my Azure portal, take the template that was in that GitHub repo that I specified, and then stand it up so I can deploy it straight from here.
Quick question.
Yep.
So is that button only for Azure template, or can we use it for the hash code, the telephone?
I mean, I would imagine anything's possible, but just ARM templates in this case. I'm sure you could build. Well, no. I mean, that's specifically engaging the Azure portal deploy template feature that we just saw. I don't think you can, you can't deploy a HashiCorp configuration through the portal.
All right.
But I'm sure you could build some sort of button or automation
Yeah, sure.
to
Like passing to some other.
yeah, but you would need, I mean, you would need a host that's running
Yeah.
the HashiCorp or the Terraform binaries to do it. But I'm sure there's something you can do out there.
All right, so that's what I'm literally calling the template to just do it inside the Azure portal.
Yep.
All right.
Now there's some little tricks. Actually, I'll talk about, when we start talking about what's new, there's a new feature that you could, I mean, I'm not suggesting that you do this, but there's ways we could hack around and do something like that. Use the button that then triggers a HashiCorp configuration, so we'll see that. Anyway, so I deployed the template using the Azure CLI. I showed how we can deploy it using the portal. And then I also showed the little GitHub button. Well, let's go see how my deployment's doing. And so we can see that it succeeded. And just to kind of see the end results, if I come over to my resource group, here's my container group. It's got a public IP address. Now this is my personal website that I don't really do anything with, but and so this is just a container running inside of Azure that I deployed with an Azure Resource Manager template. So that's, I mean, any questions on that? I mean, it was a pretty quick overview of ARM templates. What I'll do now is I'll talk about some of the new features, and then we'll go write that template, the exact same template from scratch, and maybe see a little bit more on it. So the big thing that I'm really excited about, we've already kind of talked about, and this is like, okay, this is powerful, we want to use it, we want our customers to use it, but it's, you know, it's hard. So now we need to like improve this experience. And the funny thing is, like, years and years and years ago, there was some extensions for Visual Studio that were actually pretty good. It was very graphical in nature. You brought up a wizard and you were like, okay, I want a VM and I want that and I want that and I want that. Hit go and it would like generate the JSON for you. I don't know what happened to that project, but it just kind of like they stopped maintaining it. You know, there weren't things like container. They just didn't keep it up with all the resource types. That was unfortunate, but we're now coming back around. Sorry, there was something on the screen that I don't really understand, so I'm going to try to get rid of it. So we're coming back around, and we're back in that like, okay, let's make this easier to use. And we've had a VS Code. Does anybody use VS Code? Okay, there we go. So we've had a VS Code extension for ARM templates for quite some time, but it was not great. It would lint the template. You would get all kinds of false positives. You couldn't really author from scratch. It didn't really do a whole lot. It recognized I had an ARM template. It would allow me to kind of like browse through some of the resources, which I'll show you, but it just wasn't very good. So just a couple weeks ago, we released a new one. I think it's 8.0. And the big thing that we've added, so we have this VS Code extension, but the big thing that we added is a language service, which I'm not super duper familiar with language services, but it's a .NET Core process that kind of runs alongside VS Code to do assistive things with the template. So like one indication, like the prior version, if you had a JSON file, or you had an ARM template open, VS Code only recognized that you had a JSON file. It didn't know you were working in an ARM template. It just knew you were working in a JSON file. With this new language service, you actually, like, it recognizes, okay, we've got an ARM template here, and now we can start doing some intelligent ARM template-y things. So things like comments, multi-line strings. This is a big one. Like me personally, I would run into situations, so I do a lot of infrastructure stuff. I deploy a lot of VMs, and we have this thing called a VM extension, a custom script extension for a VM. And what it does is it allows me to deploy a VM and then run a script on that VM without remoting into the VM. Azure copies the script down and runs it. Well, oftentimes I would have a script that had a bunch of arguments And so I would get into this situation where I had an ARM template, and I mean, you had to scroll like 19 times the width of your screen to like see the whole thing. So multi-line strings, case and sensitivity, open source snippets, and this is the piece that I'm going to show you. This is like where we really get into like, okay, let's author stuff from scratch. So being able to, well, let me talk about the experience prior to this new capability here. Hey, I want to write an ARM template. You open up GitHub, you go find somebody else that wrote a similar template, you copy and paste it, and then you start modifying it. Not a great experience. So these snippets, what they do is they bring in kind of like skeletal, like bare bones instances of the resources in that you can then modify. IntelliSense improvements, support for more schemas, reduction of false positives, and that's a big one. So let's take a look at it. And what I think I'll do is just write this same template from scratch, like I said. So I'm just going to go ahead and create a new file. Let's do test.json. All right, so like I said, in the past, I wouldn't even attempt this. I wouldn't even try. I would go find a template that had a container instance. But now we've got this ability to first scaffold out a bare bones template. So I just typed in ARM in this first one here with the exclamation point. If I hit enter, I now have a valid deployable ARM template. Everything I need is there. So we talked about parameters, variables, resources. The other kind of pieces of a template is outputs. This is maybe I want to output stuff to the screen. So we just deployed a container instance. I could have created an output that would have returned the IP address, so I didn't need to go over to the portal and get it or run a command to get it. But more importantly, when you start linking templates together, it's this output that would then feed in parameters for the next template to bring them together. And this last one here, functions, is brand new. I haven't written a function myself, custom functions, but this would be like, maybe I need a complex string that I use throughout my templates that I derive from other resources. I can create a function to build that string and then just reference that function throughout my template. In any regards, so I scaffolded out a template, and now I want to start adding resources to it. So I'll just put a carriage return there, ARM, and now I've got a list of all the resources that we have samples for. I don't think it's complete. I don't think we have every resource in there, but I would imagine they're kind of prioritizing and cherry picking the most useful ones. I would imagine, if I was to take a guess, I would imagine even going further in the future, we would start doing things like end-to-end scenarios. So not just like single resources, but maybe we identify that, a virtual machine and a SQL database is a common configuration, and we would add a line item just for that. In our demo here, we're doing a container instance, or actually the internal name is container group. So ARM container group. So I'll just select that, and now I have the ARM template that I need. However, it's not complete. There's some things in here that I need to configure. So like port, and it's pretty easy to identify because I've got the little linting squigglies there. So I'll do 80 for the port. CPU count, I'll give it 1 CPU. Memory in gigabytes, I'll just give it 1 gigabyte. There's some other things, like if I was to deploy this right now, it would fail because I know that this name is not valid. So there's still some little experimentation that you're gonna have to do. If I change that to any Peters, and then I need to give this a valid image. So that is a complete, a couple things to do down here. You can see they put a couple little helpers here, so I know that it needs to be one of these values. I'll do TCP, and then again, I've got a port right here. Now, there's some other things that I would want to do here, like for instance, this image. Probably don't want to hard code that in there. Maybe I want to create a variable for that. So I'll just name it image. I'll just take this value here. And then I can replace this with the variable. I'm just going to cheat real quick. So you can see I've got variables and then the name of my variable. Some other things like we have like go to definition. So I've got a large template with tons of variables, and I'm like, man, I don't know what that is. I can quickly zoom up to the top. I think I can actually, no. I thought I could hover over this and see the value, but maybe not. But anyway, so we're making improvements here. I mean, this is crazy improvements over what we had, and I think it's safe to say that they're just getting started with this in particular extension. Some other things that we haven't seen. Let me actually jump over to my more complex one. Is this outline over here on the bottom left-hand side? Why is it loading? All right, I'm gonna try it over here. What that pop-up is this schema up right here. This is a validation schema. So this is the schema that we're using to validate the template. We just released a brand new one, and the extension kind of has a little helper to like update you if you want to. I don't know why this wasn't showing without updating the schema, though it should. So we've got this ARM template outline here. So I can like navigate my parameters, navigate my variables, navigate my resources. And this is helpful as well because, I mean, again, big old JSON file. Maybe I just wanted to delete this resource right here, bootstrap creds. I believe I can't right-click and delete it, but what I can do is just select it, and it highlights just that piece of JSON inside my template, and then I can go ahead and delete it from there. Of course, I've got a trailing comma that I need to fix up as well, but again, like if you've got a huge template, just something to like help us navigate through that. All right, so back to my slide deck, and then we'll talk about two cool new features. One of them I can demo. The other one is so brand new that I haven't gotten access to it yet, so I can't demo it. The next one's called What If, and this is cool. We talked about Terraform. I didn't intend to do like a comparison of Terraform and ARM templates, but this is one of those cases where Terraform had something very cool that ARM templates didn't have, and this was the ability to see the delta. Like, okay, I've got this ARM template, I've deployed it. I'm now going to deploy it again, but I want to pre-flight the thing, like see, like, hey, if I deploy this again, what's going to get created, what's going to get deleted, what's going to be modified. Terraform has something called Terraform Plan that does this for you, and this is our kind of version of that as well. Now this is super duper, really early, and it's popping off lots of false positives, which we'll talk about right now. But there's a big effort underway to fix that as well. So how does it work? I've got our own template, and then we've got basically, I'll just blow this all out. Basically, I take an ARM template, and we've got a PowerShell command. And I can run this PowerShell command, and it basically just goes and gets, actually, let me do this. Well, it gets the resources from Azure, and then we run it through this thing called the noise suppression service. And that's the piece right there that's helping us kind of suppress some of this noise, which we'll talk specifically about that. And then it basically compares the get that we pulled from the Azure REST APIs with the put that would be created if we deployed the template. It compares those and basically gives you the deltas. The problem is that a put and a get are very different. I think the easiest way for me to explain this is, like when we created that container instance, I gave it the very bare minimum configurations that were needed to create it. So my put was like small, but when I go get it, there's a bunch of stuff set by default. And when we go get that stuff, we pull all of that default stuff back as well. So the noise suppression service kind of goes through and removes some of the default stuff. So they're tuning that noise suppression service right now. But let's go ahead. But it's going to get done and hopefully be incredibly valuable. Now the other thing is I couldn't get the PowerShell module. I'm running on a Mac here. I couldn't get the PowerShell module running on this Mac, so I've got a VM. So let me get into that. And I believe this was just announced a couple weeks ago. And then after this, we'll talk about one more feature or one more like preview thing that's up and coming. And that will be it for me. So here's just another example of an ARM template. It creates a virtual network with 2 subnets. So I've got resource type virtual networks. I've got 2 subnets defined. So we can see my JSON object there for subnets, and I've got subnet 1 and subnet 2. And I've already deployed this. So I'm going to run this command here, PowerShell command, new AZ deployment, what if. What is the scope? So we can deploy ARM templates to resource groups. But we can also deploy into subscriptions. And then something called a management group, which sits above subscription. We can have multiple subscriptions within a management group. So I deploy this to a resource group, so I'm just defining that resource, that scope right here, the name of the resource group, and then I'm giving it the template file. So all I'm doing is basically running new AZ deployment, what if, here's the name, the resource group where I deployed the template, and here's the template itself. And so it's doing the get, and then it's mocking the put, and then it's going to take the results of those. And I just deployed this I deployed this template, and then I didn't do anything else. Now we're running this, so it should come back clean. Yep. And so what we can see here is resource and property changes are indicated with this symbol, no change. We'll go ahead and change something here and then run it again and see what happens. And basically, nothing has changed. We're good to go. However, let's go ahead and just remove one of these subnets and do it again. Save that. And it seems super duper duper simple, but it was a huge, lots of requests for, lots of requests for this again. Something that the HashiCorp Terraform community is really passionate about. And yep, so we can see right away, so deleted. So we've got this negative symbol here, and right away I can see what properties are going to be deleted for that resource. And this might be a flag to me, like, whoa, like I don't want to do this, or like maybe it's not deleted, maybe it's created. Maybe I run this and I see that, like, whoa, why am I going to create 32 new virtual machines? I don't want that. So what if you do end up playing around with it? It's in private preview right now, or it's in preview right now. If you just do a search for Azure Resource Manager templates, what if? There's a form you can sign up for it. I know the team's pretty keen on getting feedback on false positives. Again, they're really trying to tune that noise suppression service. I also know they've got, they're working on trying to, automate it so they don't have to tune that as well. That'll be coming. Again, it's pretty early on this.
So can we have the what if parameter rather than what if command?
Yeah. So there's actually, it's funny that you bring that up.
And furthermore, we want to make that default.
You want to make it the default? So it's funny that you bring that up, and I'll go ahead and show this off. I'm sure they would appreciate it. So they have created a GitHub repo, ARM template, ARM-template-what if. I created a bunch of issues just a couple days ago. Again, they're asking about noise suppression, but what you just brought up, there's an issue for it right now. Somebody else in the PowerShell community obviously picked that up pretty quickly, like, why do I have this command? And there's a good reason right here. So Alex Frankel, he is on the ARM team, and he is running this project as far as I know. and he's got an explanation of why they went this route. Jeffrey Snover, so somebody posted on Twitter, Jeffrey Snover came back around and he was like, yeah, this makes a lot of sense. Let's reconsider this. So, yep. So that I don't know what they're going to do with it, but you caught it, somebody else caught it, and it's being considered.
Cool. Thank you.
All right, so this next one I'm pretty passionate about as well because it's something that I've been doing in a hack for quite some time. Before we dig into it, ARM templates are great. We can deploy stuff into Azure. We got item potency, like this is awesome. But all ARM templates deal with is like Azure resources, what we would consider a control plane operation. So like Azure understands how to create a virtual machine. Azure understands how to create a Kubernetes cluster. What Azure doesn't understand is how to go into that Kubernetes cluster and start up some containers or some pods. So that action right there is not part of the Azure control plane. Some other examples might be, I want to create a storage account and then copy some files to that storage account. My Azure Resource Manager template will create that storage account all day long, but like as far as copying files to it, that is not an Azure operation. We can't deal with that. So we've got this new resource type coming. It's in preview right now, called the deployment script resource provider. We'll actually see the resource type here in a screenshot. And basically all this is, and I actually just talked about this. All this is just really a method for running arbitrary code inside of my template. So I can do something like create a Kubernetes cluster. A AKS cluster, Azure Kubernetes Service is a resource within Azure. And then use this resource type to then run a PowerShell or coming soon a bash script that will then run some pods inside of my Kubernetes cluster. Or use the template to create the storage account and then run a script to populate the storage account. Or another example, use the template to create a SQL database and then use the script to configure users within the SQL database. So I stole these slides from the product group. So can I do whatever in an ARM template? Good news with this new method we can. The bad news, this is funny, this is what they're saying. The bad news about this is you can do it, you can run scripts with it. And here's the fear, and this is what I ran into. So we actually did this, and we'll get into the details of how this works. I mean, it's pretty much identical to how my hack works. But the bad news is, for Microsoft particularly, we've already talked about it. ARM templates are hard to write. But you want us to use ARM templates. Cool, well, I'm just going to write an ARM template, then I'm just going to blast in this big script to do all my work for But then we're in the same situation where, like, okay, well, now is your template item potent anymore? Can I continually redeploy this thing? Like, it's kind of like, at that point, why use an ARM template anyways? So, and that's basically what the rest of this slide is saying. So they want to give some guidance here, when not to use it, because something seems too hard. We're working hard to make this stuff easier. Again, if we're just writing big scripts and slamming them in a template, what have we really achieved? But I think some good examples are like so the one that I'm using, and in fact it's the big template we just showed, is a Kubernetes cluster, and then standing up some pods inside the Kubernetes cluster. Like little kind of like operations like that, I think. And we built it in a way that the scripts are idempotent in nature. The pods are already started in the cluster. We run the template again. The script fires up. It sees that the pods are already there, and it doesn't recreate them. There's a couple other scenarios here. Storage, SQL. So Linux web app is a big one. There's no method for deploying applications to a Linux web app. Networking scenarios, etc. So how does it work? And then I'll just show a little bit of the JSON. I can't do a demo. And again, this is we were able to build this basic solution without even having this provider. But what happens is you need a platform to run your scripts on. So when you create this resource and deploy the template, we are creating an Azure container instance. That's the thing that I just showed you with my little website in it. So we're just creating one of those Azure container instances. The container image that's running inside of that thing has the logic inside of it to run the PowerShell script, and coming soon the bash script that you need. So you also give it an identity. So if I'm doing something against a Kubernetes cluster or Azure, I need to authenticate as something. So we can pass to it an identity. And then there's some configuration that you can put on top of it, like timeouts. In fact, when they did the demo at Ignite a couple weeks ago, the script that they were using in the template had an infinite loop built into it. And in that case, without a way to kill that, your ARM template's just going to sit there in a deploying state forever. The other thing is, I don't know what they're doing around pricing on this, but Azure container instances are not cheap. I wouldn't run a website in an Azure container instance. It's just not the right platform for it. Azure container instances are like for burstable, like start it up, process some data, and then shut it down. Assuming they're charging for the Azure container instance time, if you get in that infinite loop, you're just spending money. And then there's other settings around retention. So it does, from what I understand, create that Azure container instance resource, but you don't need that resource to stick around forever. So there's a retention setting. Like at some point, go ahead and clean up the infrastructure on which I ran these scripts. This is something my hack doesn't do. My hack, it just stays there. You've got this stopped, useless resource that's no longer necessary. And it's got some methods inside of it to pass data from the script back to the Azure Resource Manager template or the control plane, so that you can then use outputs from that script as inputs later on inside of the deployment. So I'm super excited about this thing. It's really going to kind of increase what we can do in terms of packaging up fully baked solutions. Again, I want to, in our case, I'll kind of show you, just as an example of how you might use this. This is something that we'll be showing off at Ignite. So I've got a Kubernetes cluster running a big application. And we want to be able to deploy this application, hand over fist every time we get up on stage. But again, I needed a method for staging the containers up on the Kubernetes cluster. So just an example. But now, the same button that I showed you earlier inside of GitHub, we go ahead and hit that button. It's going to deploy the resources and then run the scripts to configure the rest of the non-control plane things. I won't actually go through it, but so I don't have a demo, but I just took a couple screenshots. Just look at a couple things really quick, and then I'll open it up for questions, and I'll be done. And again, who wants to look at JSON at 8:31 at night? I do apologize, but it's a pretty cool thing, and I'll just point out a couple things, and we'll just keep it pretty light. So there's the actual name of the resource. So Microsoft.resources, deployment scripts. I did a search for it last night. We don't have documentation on it yet, so we auto-generate documentation, kind of like a schema, like a schema map for each resource. We don't have one for this yet. I'm sure it'll be coming. Right there you can see the identity. So we've got a block to pass in an identity. Kind, Azure PowerShell. They'll be bringing Bash as well. Force update tag. So this is an important thing. From what I understand, what this does is it resources, a unique idea is created each time. this is, and then if I was to rerun this template, it would kind of like with the what if instance, like nothing's changed here. So I don't need to rerun this script. Well, you might get into a situation where like, hey, I actually want to run this script every time we deploy the template, regardless if anything has changed. So this is a way to kind of like force a little change. The timeout, okay, like I said, infinite loops. We don't want to loop forever. Retention interval. This is how long do I want to keep this stuff around. This is actually pretty cool. If you think about it, and I'm assuming theirs is going to work the exact same way. Let me go find my a set of resources that I created with my little hack. If you think about it, like, what if something fails? Like, how do I debug my script that's embedded inside of this thing? If you look at a container instance, you can actually drill into the container itself, even once it's stopped, and get logs on it. So here's logs on the scripts that I ran inside of my container instance. And so that's what that retention thing is. Like, maybe I want to keep it around for a couple days so that I can come back in and do exactly this. And you can pull these logs with command line tools as well. So I believe that's what the retention, in fact, I feel pretty confident that's what the retention piece is there. Let's see what else we have in here. Cleanup preference, so when do I want to clean that stuff up? On success. Maybe if it fails, I don't want to go clean that resource up. Maybe I want to just keep it around so that I can go pull those logs. Arguments, so if I've got a script that needs a specific set of arguments, and again, because it's embedded inside of my template, I can do something like, maybe I create a container, I'm just making something up, maybe I create a container instance, and then I pull the IP address of that container instance, and I use it as an input to an argument in the script that I'm going to call. Environment variables, so I can set environment variables and use environment variables. And then we can see right here, I've got my script in line, but I could also reference a script that's in source control. Here we can see this variable here, deployment script output is the variable that I'm going to use to then shove stuff outside of my script back into the template. So I wish I could demo that, but I just haven't gotten access to it yet. And that, I don't know how long I went. I think I went longer than 30, 45 minutes, but that's my talk right there.
All right, thank you. And do you guys have any other questions? No? So I believe Microsoft put up a lot of effort to improve our template, right? Maybe we can play with the AKS these days and script everything. But from the deployment time to deployment AKS time and the deployment by software time is totally two separate phase.
Yeah.
Now by using this one, maybe able to run everything at once. Right?
Yeah.
Thank you for your session. My question is, in the script response provider, I can use other commands like DT or SQL command or something, or say この中でサードパーティーのコマンドを実行できればいいかな。
Yeah, she basically want to run third-party command inside the script, right? Any other command. Is it possible?
Like a third-party command, like Terraform, or
an SQL command.
Yeah. So I don't know what they're going to do about that. So, like in my solution, so you're creating a container instance from a container image. So like in my solution, we could load inside that container image any third-party tool that we want. I mean, again, it's a very, very, very early preview here. I would imagine potentially they're going to enable you to provide your own container image that's pulled from a container registry that you can preload your own tools on. I would hope they're going to do that because it's a good. If I understand the question correctly, it's like, how do I get my own binaries in there that I want to execute?
Right, because this is running the Azure environment, right? Can we keep the old Power Automate instead?
Can you repeat that?
Right, Power Automate. Right, this is Microsoft Flow.
Oh, Flow.
We run the Automate
I would, yeah, I mean, I would imagine, like, so if you've got a, so I'm familiar with logic apps, is that?
They're kind of the same, yeah.
They're kind of the same?
Yeah.
I mean, I would imagine if you've got a logic app running, or created, then you could use this functionality and PowerShell commands or CLI script to trigger that logic app.
Right,
from the
it's
template.
HTTP endpoint anyway, right?
Yeah.
Okay.
Great. I appreciate it. Thanks for having me. Oh, yes.
You said the execution is like a container, but the user executes the script in the long template. How do you put it in the fully automated pipeline? Should it be a real user, or is it okay with the service principal to run this kind of?
Yeah, so I haven't got hands-on with this. I believe you're passing in a service principal. But what they mentioned in their Ignite talk is that they're going to enable managed service identities. Are you familiar with the managed service identity? And so if they do that, I imagine you could do something like this. Again, kind of like making some assumptions, but I'll show you what I do. And I gave them a lot of this stuff. I don't know if they modeled it off of this, but I would imagine, well, here's what I do. I think it would be cool if they do the same thing. I'm actually, let's see if I can blow this up. I'm actually creating the managed service identity as a resource in my template. So this is cool because like, I'm creating the identity on the fly. I'm then scoping that identity. I'm creating a role assignment, giving that identity access to just the resource group. Obviously, it could get pretty messy if I went beyond that. And then when I create a container instance, I'm giving it that identity. So I'm creating an identity, giving it its scope, and then assigning it to the container instance, which is cool because now inside that container instance I can create Azure resources. I'm assuming they'll do something similar to that, but just looking at what they provided here, you can actually see that the identity, they have it as a parameter. So user-assigned identities, we've got parameters, user-assigned identity, which indicates that they're passing in probably that service principal at deployment time. So I don't know, it'll be interesting to see what they do there.
One more question.
Yep.
Since it is an Azure deployment resource, I can use Azure policy or something like that to prevent users execute scripts, right?
Absolutely. Yeah, I mean, a policy is like, it's, you know, you can set it at the management group subscription or resource group wide, so absolutely, I mean, if you want to prevent something like this from happening, you could set that policy to do something like that. Policy doesn't care where, you know, the effect is coming from. It's going to stop it if that's what you want the policy to do.
I have a question. Every time we announce something, we can do this. Then before asking, is it possible to preview the first one? All right, guys. So thank you. Please give me a big applause again. All right. So we take 5 minutes break, and after that we Jim and the speaker.
Thank you very
Thank
much.
you. Thank you. And Jim, Mr. Jim, please come in front.
And if you want to provision to the second screen, please reshare your screen.
Yeah. I did.
Yeah, so everything's supposed to right here.
Yeah, I have to
Like that.
refresh.
Either my, let me do that. There you go.
Oh.
Yeah. Cool. All right, we'll be back in 2 minutes.
We share pizza, please eat up.
I'm going to share from directly this screen.
Yeah, then that.
Where it's actually sending out.
It's very kind of thing.
Okay.
It's very important to do it, this kind of thing.
Yeah. I like this one. Have fun. And you are sharing your primary screen. Oh, wait. Just check. The YouTube screen is a bit slow for update.
Oh,
So it's still showing the. Yep, there you go.
which one is it going to show?
This one.
It's going to show this one.
Yeah,
but
that
that's
one. So you need to share the second screen.
Oh. But it's supposed to be
No,
round.
just quick. No, don't exit. Just go the. Just do the presentation mode. Go to the presentation mode. And after that, just click this one.
This?
Yeah. Then you should have the status bar. Then stop sharing the browser. Your browser. And stop sharing and reshare to your scan screen.
Oh, yeah. Are people going to hear me on YouTube?
Yeah, there you go.
Is the audio on
Yeah.
for,
This one.
for YouTube?
Mm-hmm.
I'll double check.
Check.
Okay, I heard myself.
All right, so shall we start?
Sure. Is everyone packing here?
Yeah.
No one's outside?
No worries.
Okay. Well, hello everyone. I'm presenting once again, but this time I don't usually come to the Azure Meetup, so I see quite a few people here that I don't normally see at the other .NET Meetup. So my name is Jim, and I'm an engineer at Couchbase. I was in charge of the .NET mobile product for quite a while, but now I've moved into another role of I'm sort of burrowing myself deeper and deeper into the product. So now instead of working on the .NET part of it, which is sort of developer side facing SDK, I work on what it wraps, which is a C++ core. But I still do a lot of tool development internally for the company, and when possible, I use .NET to develop the tools that I then share to the other people in the company. And I've run into a fairly unique problem. The people don't want to use .NET. I don't know why. I mean, I'm a pretty biased person myself. I've been using C# since 2007, so 12 years now, and I like it a lot. And compared to where it was just 5 years ago, using .NET on multiple platforms is so much easier than it was before. So this talk is called Distributing .NET Programs to Non-.NET People. And the thing I hear is, I don't want to download the .NET runtime. That's an annoying extra step that I don't want to do. Well, okay. I'll appease you with this. So, first, let's go over a overview that I'm sure most people here are familiar with, but is required understanding for why this is a problem in the first place. So, what is a .NET application these days? First of all, you have, for .NET Core, which I use almost exclusively instead of the regular .NET framework, .NET Core runtime, and actually .NET runtime, the framework runtime as well, is nothing more than a C++ program which manages memory, consumes and executes IO language among other tasks which are designed to make your life easier and the stuff that you really don't want to do when you're writing C++. And then the actual applications that you run are just IO language binary files that the runtime then takes and executes as they're written. IO is just a language that was developed by Microsoft to be a sort of halfway point between C#, or a number of languages actually, since .NET is more than just C#, F#, Visual Basic, there's even C++, there's all kinds of stuff that can go into the .NET runtime, but at the end of the day, it gets compiled down to IL, and then that IL gets compiled by the runtime down to optimized machine code for execution. So, therefore, according to that, downloading and installing the .NET runtime is usually a requirement of this process, or else you can't run it. But the key point here is a feature in .NET Core, not .NET Framework, but .NET Core only, called self-contained application. So, first, the thing you have to do is you have to do a .NET publish instead of a .NET build. And you have to use the self-contained flag, self-contained true. You have to choose the runtime architecture and operating system that you're targeting. And what that does is it will copy the needed parts of the .NET runtime into the application output alongside of it. So if you were to take that directory, scoop it up, and give it out to people, then you would have everything you need right then and there to run the application without any extra .NET runtime dependencies. That is, dependencies on the .NET runtime. On Linux, there are still a few native dependencies that you need, but aside from that, I mean, the native dependencies that you need for .NET Core applications are basically stuff that you would have anyway if you had any sanity at all. So an example of this is .NET publish self-contained runtime Win7x64. You can do Win1064. There's a whole list of these that are called runtime identifiers, or RIDs, and it's kind of adorable if you look at how they all sort of like branch out from each other. You start with like Unix, and then you go up to Linux, and then you go up to like Linux 64-bit, and then you can go up to like Ubuntu or. But so with that being said, there are a few other things that need to happen here.
Yeah, Jim, sorry, could you reshare your screen?
Reshare it. What happened to it? Is it gone?
Yeah, it's gone.
What?
maybe my fault.
Oh, stop that. Don't do that. All right, here we go again. Sharing again. Screen 2. There, now what we expect. Okay, it is there. Is it happy? Is everything working now?
Let me check. No coming up yet.
Well, let's assume it's coming.
Yeah.
And the solutions that I use for building this are twofold because, well, I don't want to say this because I know I'm wrong already, but there's no one solution that will build all three platforms that I want. But then I discovered that Azure DevOps and Pipelines will build all three of them, but I only thought of that this morning, and I was unable to complete a fully working pipeline in Azure before this presentation. So, but actually I got it mostly working. It's just that I discovered that when I deployed on Azure, I was using .NET Core 3, and .NET Core 3 and a package I was using do not seem to play well together, so I kept myself back, and we're using Travis for Linux and Mac, and then AppFair for Windows. These are both free for open source projects, and maybe non-open source ones too. But today's application is something I wrote called the Troublemaker Proxy app. The reason I wrote it is because what we work on at Couchbase, what my team works on, is a mobile solution which is an embedded database and data sync solution. So syncing data, well, we have a lot of tests that test, okay, I did a sync. Is the data on the other side? Well, we almost never get bug reports about things going right. So how do we get things to go wrong? I mean, how do you say like, oh, the sync should just sort of fail at this point in time, or the network should just drop in this deterministic way? So without getting too much into what this application actually is, because it's very Couchbase specific. It's an open source tool I work on for testing at Couchbase, which basically sits in the middle between my client and my other side, the local and the remote, and just causes trouble. It'll disconnect the network, it'll make the network really slow, it'll mess with the messages being sent, it will twiddle with the bits being sent so that the bits end up wrong on the other side. Just all kinds of fun stuff to basically destroy the process and see what will happen if we just throw a monkey wrench into the works. So it's kind of like network fuzz testing, basically. We haven't really automated it yet because I'm still convincing them, hey, you can use this without using the .NET runtime, you know. But so the application I wrote has one native dependency, and that dependency is just for parsing and repacking the actual network packet messages. I didn't feel like rewriting all of that in .NET, so I just wrote it in C and wrapped it in pinbook. So the main application does nothing. All its functionality comes from plugins, which is not that interesting right now to come into play. The application is .NET Core, and the plugins are all .NET Standard. And a shout out to Nate McMaster on GitHub, who has a very excellent command line argument parsing library for .NET, as well as a dynamic plugin loading library. Both of those came from him, and I use the argument parsing one in every single .NET application that I build. It's just a really nice way of doing things. So the thing that I want to do here is I want to build 3 versions of the application which are not runtime dependent, one for Linux, one for Mac, and one for Windows. So that way when the people come to me and they say, I want to run it on Linux, I can say, here you go. They come to me and say, I want to run it on Windows, I say, here you go. But the plugins, I just want to build them all once, because they're not executed by the system, they're executed by the application, so they're all IL, they don't need any runtime dependency. And then when it's appropriate, I want to publish to GitHub releases, because the artifacts that you store on AppFair and Travis will expire after a given period of time, and then they'll just be gone. So if you don't make a release for a given number of months, then suddenly you lost it. Oops. Alright, I only made 6 slides today, and the rest of what I want to talk about is in here. I have these two files in here. These are files that are in the actual GitHub repo. And it's very similar to what the last presentation was talking about with this sort of describes what you want to do as code. It's a config as code, and so you check it in with your code to see what you want to do. So I'll go through, this is the app layer configuration, so this is only concerning itself with Windows. And a lot of this stuff is describing the environment that's being built in and what to do before you actually build. So going from the top, this is a version, and I don't care about the version that much because I don't actually use this number. It's just a number for app layer itself. So it's always going to be 100.build. And the build is a number that it calculates, so it's just whatever. So I only want to build the master branch, and I want to build, they say branch, but anything that is checkoutable is a branch according to app layer rules. So if it's digit.digit.digit, that's a tag that I put in, and tags are considered branches as well. So if I make a tag, this is a key functionality that I'm using. When I make a tag, it will make a build, even if I didn't check in any new code. So then it runs the auto fix up the end of line thing for Git, and I'm running in Visual Studio 2017 and cloning only one level of Git so that it clones really fast. And here's the actual build. It's just these. So this is standard CMake stuff. I go into a clean build directory. I run CMake with 64-bit, and then I run the CMake build command because I'm not insane enough to try to mess with command line C++ building for Visual Studio. I'd rather just have CMake take care of all that for me. So I just say build this with this config, and it does all the MS build magic for me. That was a really happy day when I discovered that. Then I do what I was talking about before, and I'm still at the root level, so this is at the solution level, not the individual project level. So I do a .NET publish, the release configuration, and this will build all of I have in the root, I'll show you. Let's see. I forgot how to make these huge. Let's see. Extra large icons. So I have the main program here, Troublemaker Proxy. And then I have a series of plugins, this plugin, this plugin, this plugin, and this plugin. And so now I'm running from here, .NET publish. It will build this, it will build this, it will build this, it will build this, and it will build this. But then I go inside the Troublemaker Proxy folder, this is what the program is, and I run .NET publish with the self-contained flag. So that out comes a runtime independent build of the application. Then I keep forgetting if I need this or not in PowerShell, but I find that if I don't pop the location at the end, then it won't go back to the original directory like Bash does. I don't know if it's my imagination or not, but whenever I'm in PowerShell, I always pop location. If I've pushed like 3 times, you'll see pop, pop, pop at the end of my scripts. And one day someone asked me why I did that, and I didn't really have a good answer. Then this is just me being kind of incompetent because I don't know how to do it otherwise, but I don't want a whole bunch of folders inside my zip, so I move the publish folder into the root, and then I zip up each one of them. And this will create artifacts for them. And this is one of the fun parts of AppVeyor and Travis. I have this AppVeyor repo tag, which is a Boolean value that says whether or not this was built based on a tag or not. If it is, then I want to deploy to GitHub. If it's not, then I don't want to deploy to GitHub. So otherwise I'd be deploying every time I push to commit. But if it is a tag, then I'll have this tag name available. And that's just the name of the tag that I made, and that will be the name of the release on GitHub. And I put this force update on here because Travis is actually going to be attempting to write to the same release. So if I update here, it'll see that the release already exists and be like, no, you already have that, stop. So over here in Travis, you have a little bit of a different configuration setup, still YAML, but I tell it that it's C#, and I have a matrix this time, and I have .NET installed with Ubuntu Linux. Xenial is Ubuntu 16, and I have libunwine, which is one of the dependencies of the .NET Core runtime. The others are installed by default, so I don't really need to care about them. I have environment variables. I have the RID set to Linux x64, which I'll use later, and then I have a Mac OS set up, which doesn't have as many things, it just has the RID set up as well. And then, once you get into the script, you'll notice, wow, it looks pretty similar. I do the CMake stuff, except instead of CMake build, I just do a standard make commands. That builds my C dependency, and then .NET publish with the RID variable, either Linux 64-bit or OS X 64-bit. It's kind of unfortunate that they got this name before that Apple changed the name of Mac OS to Mac OS, but that'll just forever be a legacy quirk, I guess. And then, same thing here, except I don't care about the plugins this time. Remember, I don't have to build them per platform, so I'm only building this, this app. And then I go in there and I zip up the troublemaker with the RID in the name. And then this is kind of the same as before. On tags, this says if it's a tag, I want it to do deploy. It deploys to... This is not, by the way, this is not my actual API token. The secure stuff, actually you have to run it through Appfair or Travis first, and then it spits out the encrypted one that you put in here. It's fun. I like it. But this will do the same thing as before. If there's a tag, it pushes it to GitHub. If not, it just sort of builds it and tells you if it broke or not. So when I'm building it, what I like to do is I push up my changes and then make sure that when I'm done with my changes and I'm ready to make a new release that my build passes. Then I make a tag. That action of making a tag starts my release process. So I can probably just do it here. See here, you can see me here trying to get Azure Pipeline to work. Azure Pipelines has this fun feature where you can just sort of type in your new deployment configuration into the portal itself, and it will write it to GitHub for you. And I just left in the default message 5 times before I got it right. But more on that a little bit later. Here's my latest release, 1.10. So let's see if I can make it 1.11, and if it doesn't work then, well, that's too bad. Create tag, and then push 1.11 to origin. And this should, let's see, let's go to app there. Yep, it started a build of this. And on Travis, CI Travis, Travis CI. Travis CI. Also have a build going here, and you can see the matrix set up like this, which is remarkably similar to what Azure Pipelines look like. While this is sitting here building, let me go to my failed attempt to try to use Azure. I got pretty far, but not quite far enough to make a full presentation out of it. See, I have, what I did to get this far was I went in here, and I made a new project based on my GitHub URL. And I went into here into pipelines, and I set up a build pipeline by going here, I think new pipeline. Oh yeah, new pipeline, and then I chose, it was in GitHub, and I already had a configuration that I wanted to use. And that resulted in the configuration which looked like this. That is tiny. So, similar to Travis, I have a strategy of a matrix here, and I have some variables that I have in each one. I have the Linux build, the Mac build, and the Windows build, and Max Parallels 3, so they'll all build at the same time. Well, approximately the same time, depending on how full the stuff is. And then when I create the actual thing that I want to run it on, I just say VM image is going to be this image name up here from the matrix. And then I run an inline PowerShell script, which does, oh, this is an older version, isn't it? That's too bad. I didn't actually pull. I should just pull. That'll solve it. I updated this so much in the portal, I never actually pulled it down to my machine. Alright, so here we go. I have to get submodules, so I have submodules in this project. I have one submodule, so this will check out the submodules for me. And then this is a lot cleaner than actually Travis is because they have a lot of pre-set up things already. Like they have a CMake task, so I just give it a working argument, working directory, and I have CMake arguments up here because they're one way on Unix and another way on Windows. So I just build that. Oh, that's all good. And then if my image name is not Visual Studio 2017 Win 2016, then I do the native Unix commands, and if it is that, then I do the native CMake build. Then just do a .NET Core publish here with these, and good to go. But the problem was that one of the .NET libraries that I was using does not work well with. But here's what it looks like. Here's what it looks like. You got this list of stuff that ran job Linux, job Mac, job Windows, and I like it. It was kind of working. And inside here you can see like each part it'll split it into each part for you. It's real nice. But ILlink.tasks, no, it's not having it. Something got renamed and .NET Core 3 won't work with it anymore. And since it's a preview release, Microsoft's just let, or whoever's making it, I think it's Microsoft, but could be wrong. But let's go back to here. So the build passed. Let's see what went on in here. So job log, so you can see like here it's building the native dependencies. Dun, 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 dun. It's a very small native dependency. It only has 5 files. Made that, started installing .NET Core runtime for the .NET Core SDK, and this is all IL linking to get rid of all the stuff that it doesn't use. Otherwise, your Hello World program is 65 megabytes.
Yeah, or even more.
So here's all the stuff, how much it saved. It gives me a nice little table of everything, but it worked. And then since I made a tag, it's deploying my application. And how about over here in AppVeyor? AppVeyor also succeeded, very nice. It has the same bunch of noisy output at the bottom. But at the end, since it's a tag, uploading to release assets. And actually, Travis doesn't have any artifacts, that's right. Only this one has artifacts. So you can see here's the artifacts that I created. The 4 plugins and the Windows 7 variant of the Troublemaker proxy itself. And on here, what it uploaded was, does it actually tell me? No, whatever. Let's go to releases. So there's my latest release, but not anymore because now I have 1.1.1 over here in GitHub. And I have all of these artifacts here for me ready to download. A Windows version, a Mac version, and a Linux version. And I downloaded the 1.1.0 earlier. So let's see what happens if I actually run. This is not the one I downloaded, but if I run just like this from the project directory, it's gonna start up and it's gonna ask me for a path to the configuration file. This is as far as I'll go with the application because beyond this it's just boring space specific stuff. So I just want to show that if I go to, if I can actually type correctly, I have the Japanese keyboard still on. Users, downloads, Troublemaker proxy, Win 7, x64. You can see in here just a whole buttload of stuff, but the important one is here. Oh, I don't want to do that. Troublemaker proxy.exe. And this was, I made this before .NET Core 3 came out and made it default to have this executable in the output, which is still actually runtime dependent. This is completely runtime independent. I could fire up a pretty much empty Docker image, just run troublemaker proxy.exe, and then immediately it does the same thing. Enter the path of the configuration file. But this is running the .NET runtime not from the system, but from, as you can see here, core cll.dll, host fxr.dll, host policy.dll, and clr git and compression.dll. These are, I believe, all of the things that are actually running the runtime. Everything else is built on top of that. You can see my McMaster stuff here, command line utilities and netcore. I really like it. So next time, well, maybe for anybody in here, the first time someone comes to you and says, I don't want to use it because downloading the .NET Core runtime is annoying and too hard and I don't want to do it. You can respond by doing this. Then they won't have any excuse to not use your wonderful .NET application anymore. Because I could write the same thing in C++, or I could write the same thing in another language, but it would take me days or weeks longer to do it. And instead of just taking this little bit of extra effort to compile it all the way down to a non-runtime dependent executable, and then just give it to people and say, you don't even have to tell them it's running .NET, just say, I made this, you can run it. That's the end. And that's also the end of my presentation.
Yep.
Alright, any question?
It's kind of hard to have a question about this presentation because my presentations don't really have a theme. They're mostly just, I did this at work and I'm going to tell you about it.
Right, and one additional, because this is kind of very much for just copy and move it forward to the new computer to just run. But for the .NET Core 3, we also can compile it to one file if feasible. So you don't have to copy a bunch of files, just pass to one file. It contains everything.
Yes, that was the topic of my presentation 2 times ago.
Yeah. All right, thank you. All right, so that's it for today. And for the next time, because it's already December, I don't think we have another meetup this year, so maybe we shall see you next year. So have a happy holiday and a happy new year. Bye, YouTube. And before you guys leave,